Hi everyone, today's objective is a quadratic and projectile motion. Now before we do that, we need to talk about what is a quadratic equation and what is a quadratic equation look like, and the graph that will give you from a quadratic equation is going to be called a parabola. The graph of quadratic function is a parabola, which is a U-shaped curve. When graphing parabola, we want to include certain points: the y-intercept, the x-intercept, the vertex, and line of symmetry. Now, just in case you guys don't remember, I relay my parabola shape, but it looked like a rice ball. So that's how I remember that the parabola shape is rice ball shape too. Notice in the pictures, they tell you the location of the vertex, they tell you the location of the y-intercept, and the location of x-intercept and the x-intercept. So now we're going to talk about how to get them and how to determine where everything located. So the graph of y equals x squared is a parabola, and then also y equals ax squared is also considered to be that. Y equals ax squared plus bx plus c. Now that's something that you have to know, that is highest exponent is 2. That's probably the most important thing. And then so because that x exponent is equal to 2, there's another thing that on the bottom is also say quadratic equation in 2 variables. So in this case, 2 variables are x and y. An equation that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot equal to 0, because if a equals 0, then your first term x squared will be gone. So therefore that a has to be some sort of number. So now what you would look at in the pictures below, parabola that opens up is a positive, right? Positive U shape, and the x symmetry goes in the middle, and the vertex is the minimum point. I'm telling you guys this way. I say, hey, my rice bowl is happy, it's positive, it's facing up. You still have lots of rice. And then parabola that has opened down is negative, and my rice bowl is sad. So if you flip it around, there's no more rice, and then it's a front face. Positive, happy face, sad, front face. That's another way you can remember. More rice, happy, facing up. No rice, facing down. No more rice for the rice bowl. Axis of symmetry. And if you look at axis symmetry, you notice there's a line in the middle. And if you have a line in the middle that says a line that divides a graph into 2 symmetrical halves, that means they are equal to each other. That means when you fold the paper together, they match point by point on each side of that symmetry line. Going on a couple other things on the axis of symmetry. One, axis of symmetry is a vertical line that passes through the vertex. If you look at the picture above, you notice that's the dotted line, and then so symmetry line is a vertical line that passes through the vertex, divides the parabola in half. You can tell by the picture above. Each side of the parabola is a reflection of the other. That means that exactly match. The next one, axis of symmetry equation is x equals negative b over 2a. So in this case, if you know what's your a, b, and c, you can actually find the exact location of the symmetry line. On the list is going to be vertex, because on the symmetry line, that's going to be the highest points and lowest point. And if you look at the picture above, that's actually the vertex, right? So this is the symmetry line, and here's the vertex, and this is the maximum point because it's the highest point, and this is the minimum point because it's the lowest point. And then you know axis symmetry, and then you know a whole bunch of other stuff as we start talking about it. Vertex of parabola is the lowest point of the parabola that opens up, and the highest points of parabola that opens down. So if you think about it, common sense tell you open up, which is when you are happy, that's the lowest point, and when you are sad, that's the highest. So there's a formula again that's from before. I'm just putting in order pair form for you. X coordinates of the vertex is negative b over 2a, and that's only the x coordinate. The vertex is maximum point if parabola opens down. The vertex is minimum point parabola opens up. So I just want you to understand that, because eventually we're going to use that information a lot for word problem. Next one, to get y coordinate of the vertex is to plug in the x coordinates, which is right here. Whatever that number you get, you're gonna plug back into the original equation, whatever the equation they give you. All right, so we're gonna definitely practice all this in a couple minutes. Then that last thing is the y-intercept. Really, the y-intercept is when x is all equals 0, because you are looking for y-intercept. If you are looking for y-intercept, x has to equal 0. And when you put in everything equals 0, anything with the x drops out. So therefore, the last number on your equation, which is going to be the c. Now, c could be in different position as long as it doesn't have the x. C will be your y-intercept. With the very first example with you, and then we can go on and do different things. Couple of things I want you to start. I want you to naming the ABC. A is the number in front of the x squared. So in this case, it's 1. B is the number in front of the x. So that's -6. And C is the one that does not have an x. So that's 3. Now, because A is positive, so when you're looking at A is positive, happy rice bowl. So in this case, A is greater than 1, positive, and then A is less than 1. Okay, so A is positive right here, so it's gonna open positive, so it's gonna open up. And then find the y-intercept. And y-intercept, you guys should know, is the last term where the c is. So in this case, c is just 3. And find the axis of symmetry. To find the axis of symmetry, you have to remember to use the formula. And the formula is going to be the -v over 2a. And I have you guys write down what's your a and b and c last time. So it's really easy just to type it, plug it in. So negative of -6, please write down the step of what number you plug it in. It's very important. 2 times 1. And then you have -6, actually positive 6 over 2. And then that 2 right here is going to reduce it. 6 divided by 2 is going to give you 3. So that means that your x-axis equals 3 for that symmetry line. Then once you find the symmetry line, that don't forget that's the x coordinate, and that's the notes I gave you before right here. That's the x coordinate. That's what your x-axis is. Then I'm sorry, axis of symmetry, and that also is your x coordinates of your vertex. And to get y coordinates of the vertex, just plug in the x coordinate back into the original equation. So that's what I'm going to do. I'm going to take the 3, plug into my equation before. So that's going to be y equals x squared minus 6x plus 3. So plugging 3 for my x, that's going to be 3 squared minus 6 times 3 plus 3. And then when you do that, that's going to be 9 minus 18 plus 3. And that is going to be -6. So your vertex is going to be 3, comma, -6. On to the next step. What points is symmetrical to y-intercept? So now what we're going to do is, the best way is for you to plot the function or plot the parabola. So let me show you how that is done, and then we can come back and find the symmetrical point. So in this case, we say the symmetry line is x equals 3. So x equals 3 is right here. All right, and then you have the vertex is 3, -6. 3, -6 is 1, 2, 3, 4. That's 3, comma, -6. And then don't forget, this is a parabola that's facing up, so it should be a happy parabola. So now what you have is you need to find your y-intercept. Now your y-intercept in this case is whatever is going to be on the y-axis. And then I told you guys that's c. And since c is 3, I'm going to plug the 3. And then you also know the symmetry line cuts the points into even parts. That means one have to be able to flip and get to the other one. And in that case, that if that happens, we are going to take this 3 right here and flip it over, and I get this point. And that is your symmetrical to your y-axis. And that is going to be 6, comma 3. And that is also called the symmetrical. So now once we have all those points, we can totally just graph it. Now eventually we're going to be able to have an x-intercept, but right now we are not going to have a chance because we need to be able to factor and figure out different things, and this problem is not the case. So there's your parabola, and they want you to label everything, so let's label everything. And this is the y-intercept, and that's your c, so it's 0, comma 3. And here's your vertex, and this is your symmetry line, axis of symmetry. I would like you guys, what is the symmetrical to y-intercept? And to answer that question, I'm going to put down 6, comma 3. So please pause your video and then try example number 2. Change the y-intercept should be 0, comma 3. I would like you guys to try example number 3. Example number 3, I would like to give you guys a little hint to start, and that is a equals 3, but since we don't have a x term, so b is going to be 0 and c is going to be negative 5. And go ahead, give a try from there. Go ahead, please give a try from there. For the purpose, because we don't have another y-intercept, the vertex and y-intercept is the same, I am going to pick a point that's next to the line, the symmetry line, and that's going to be at 1. I could pick negative 1, but 1 is easier to work with. So for example 3, please take a look at it, and today we are going to stop our notes at example 3, but make sure you do your homework on the homework section number 1 through 4. Thank you so much for watching.